So I'm mostly going to wear this hat about my analyst position at NC's in Santa Barbara, working with the Ocean Health Index and just diving into a little bit more of the tools and data involved in calculation of the Ocean Health Index, specific to really to distributions, because I want to segue into some discussion about how we can get a better handle on the distribution of these animals so that we can do that strategic time and space interaction, strategic kind of placement of activities. And I thought it was a great question about this, what are the units of the axes with the trade-off? And really these come down to frameworks where these are big societal questions. And so I want to show how Steve Katona mentioned how these weights are pretty fundamental to the final answer. And I'll show you just an example of how that comes into play with the Ocean Health Index, and Evan's going to show you an example of how that comes into play even with the stressor weightings in the black box that Jeff Moore was mentioning with his question. So, okay. Come on. Okay, so yeah, we'll talk about Ocean Health Index. You'll see the goals and how we can weight those, dimensions. Really, when we were talking about cumulative impacts, that's jargon-wise, it's almost equivalent to talking about pressures, what we call pressures in the Ocean Health Index. The only difference is that then the pressures are on a per goal basis. So I'll dive into that a little bit. And then a toolbox that's my prime directive is in allowing other people to play quite a bit with these different input layers and equations and weights. So I'll show you what that looks like, and I'll mention some regional applications, dive into species, and then I'll get into distributions and data and just encourage use of this, a geoportal that is related to work at Duke, and then that effort for doing the cetacean mapping side of the cetacean and sound mapping project, and just segue into Evan's talk with Mark Sand, because we'd be remiss not to mention it for talking about marine spatial planning. So this is just a reminder of what Steve already showed with the different goals, and so it's quite broad. I mean, you could also consider these as just sectors of human benefit from the ocean resources that we glean. So really the trick is how do we then weight these? Right now these are roughly equivalent across the 10 goals. They are equivalent as far as the weights go. And then the sub-goals have just half the weight of the full goal within. So there's provisioning food and other resources as well as our livelihoods. So, and then of course we get a map, and in this case the reporting unit is per EEZ. So that's exclusive economic zone, and the idea is that we want to enable this to happen on a finer scale that allows us to understand management. But really there are different tools for different purposes. So this is really helpful on a broad monitoring level to get at least some sort of baseline about how we're relatively doing. But then when it comes down to local decisions, maybe something like a trade-off analysis is more appropriate. So that's an interesting discussion point. So again, the way this works, there are these dimensions per goal. So we've got a present status that's based on a reference point, and then that is worth half of the final goal score. The other half is the likely future, which is based on taking the present status, the trend of how things have been going, and then inferring that they're going to continue to go that same trend, but inflected by what pressures. So if there are more pressures than resilience factors, then it will inflect that trend, that likely future state, either up or down. So pressure is downward, obviously, and resilience upward. So, sorry, this is pretty tight. This is, again, Steve already mentioned this, and this relates to what the data looks like. So here, this is very similar to we've got the pressures column-wise, and then we've got the different goals. In this case, just one goal of biodiversity row-wise, and then it's broken down further by habitat. So different habitats have different stressors. And then in the case of the species subgoal, it only has just one set of stressors. But we already saw an example where that could be broken down from Sarah Maxwell's work and by specific species. So again, just a framework for playing with these final weights that then get added up. And so I'm just going to mention that this is not just it's not supposed to stay within the confines of just this NC scientific group. We want to make this available so that anybody can go in and play with it to understand it, and then also to tweak it in a way that's regionalized and at a finer grain for relevance to specific countries that tend to plan not on this global level, but on a more local level. So we've got an application that has a friendly user interface. We've got workflow tools, like in ArcGIS Model Builder, you can drag and drop, take the output of one tool and input to the other. You don't have to be a programmer, you can still make the thing work and iterate through. And then if you are a programmer, you can have the full kit and caboodle. And then using the R open source cross-platform engine to then drive the statistics that then interact with the data, and we'll have some web services. So that's just the software stack. And yeah, wow, can't see that at all. But what it's showing is on the far left is there's the index. These little lines that connect then the 10 goals. And then for this coastal, this one goal, one column over is then the sub-goals of the coastal livelihoods and economies. And then you see livelihoods and economies broken out, and then you can click again, and then it drives down into the dimensions, and you click again, and then you see the input layers that then feed into that dimension. So in this case, you see the input layer of, for the economies, or excuse me, the livelihood sub-goal, we're looking at the pressures dimension and seeing the input components to the pressures dimension, which includes MMW, which is the layer that is marine mammal watching. So just a way to drill down into the Ocean Health Index so you can understand it, and then even potentially swap out layers if you want to have your own application. And then you can map it, of course, and zoom around and click on things and look at histograms and tables. And then you can play with sliders with goals so that it starts off, with one set of default goals where every goal is weighted as say 1, and then you can slide that around. So in this case, let's say this person is a climate skeptic and saying that carbon storage and coastal protection aren't something I'm concerned about. And I'm going to bump up the provisioning resources or things that are important to the economies, like mariculture and fisheries, and you get a different answer. So that gets back to this, it's a framework for bigger societal questions about how we weigh these things out. And then this is just an example of 2 publications that are either submitted or very near, i.e. within the next week, going to be submitted, that show you now, instead of the EEZ being the reporting unit, now for the California current, using these regions within the California current, and then for Brazil, using the states for Brazil, so that we can manage it more appropriately. So then if we, for the global analysis, we came up with this is the final score for the species sub-goal. So that is composed of all these IUCN distribution maps, and just taking the original polygon map, gridding it out into half-degree cells, and then assigning based on the endangered status of the animal, and then adding those up and getting basically an average, and then doing an area-weighted average to get at the EEZ level. So that's how that goal got its status value, basically. But now I want to just use that as a segue into understanding just more about distributions and the kind of data that we need to, that these indices then use, and then how that relates to you as researchers. So here's an example of just the IUCN distribution map for the gray whale, and you see that the coastal affinity of the gray whale, and that looks like a helpful layer for planning purposes if you're at this global level. But then you look at the distribution map of a humpback whale, and this is probably not very helpful. We got a global blob. So that's that's interesting. So these are based on experts convening around a table and identifying what lives where, and that isn't telling us a lot. We also used we might have had IUCN status for some animals, but not one of these polygon maps. So we also used aqua maps and used a 0.4 threshold. Now this is a little bit more helpful as far as at least pointing us towards relative densities of where things live. And we still, for our aggregate level, we had to break this down into binary blobs, but that's using now habitat affinity with a few predictors like sea surface temperature and distance to ice and depth. But really the gold or standard, or I should say the blue ribbon standard, is PBR. I'm not talking about perhaps blue ribbon, I'm talking about potential biological removals. So to get a PBR, we need to get more information like the angle and the distance away from the survey vessel, and have scientific observers on board. And so the figures in the lower left are showing ship or plane, and then we can get at things like detectability and incorporate that into our understanding of actual density surfaces. So that's what we really need. And so now we're talking about other types of data beyond just expert opinion that really get at the management driver. So for doing these environmental impacts, we need that PBR. At least that's a current standard, and we obviously should be relating things to density. So now we need to capture these data types, and we saw the first example, telemetry being used for habitat. I like the notion of it being able to tell us more about the behaviorally important areas. So area restricted search kind of methods tell us if there's a tight turn angle and short step length, then it's probably doing something like feeding, or maybe narrow turn angle and long step length, it's probably migrating. And we would expect that there's different stressors and different things impacting them in different ways based on the type of behavior they're exhibiting. So getting at that would be cool. And then I think just engaging things like citizen science and opportunistic things like iNaturalist is a great site for that. We've got obviously a lot of other types of data that can inform on the density and distribution of animals, including acoustics and photo ID genetics. So I just want to just give a little quick plug to say, check out OCMap if you haven't already. It's really great to be able to do these kinds of exercises on a publicly available data portal, and this is specific to this community. Related to the cetacean sound and mapping group, most all of the data sets are on this portal. You can't necessarily do the density estimation with how they're downloadable yet, and there should be some step where you get the OK clearance with the original data provider, but it's only a few clicks away. And yeah, so once you do that, then you can do things like this. This is some funded work from originally Navy, actually sponsored in part by Bob Gisner, who's in the audience, which is great, and then also subsequently NASA. And just an interface where you could draw a polygon and extract the actual densities, if that's a potential planning area, and get at the original input data that went into that. So you can see the survey tracks of effort and the observations, and that's pretty key. You can look at the models on the left and just drill down with a hierarchical list of the regions, the seasons, and the species, and then understand where these things are happening. And then you can do things like, this is just an ROC curve, which allows you to look at something like if you're looking at just habitat, not density here, you might be more risk averse for some animals than others, so you might want to be more liberal with the threshold at which you apply to go into some go or no-go decision. And then this is the culmination of a lot of effort, and really in the Pacific, really Southwest Fisheries Science Center folks, Elizabeth Becker, Karen Forney, Jay Barlow, a lot of folks contribute on the West Coast to the models that you see, and there's a hierarchy here of preference where we'll come on back.
Very large spatial scale.
Yeah. Oh yeah. Okay, we're going galactic, folks. Oh man. Okay, so then we got habitat density, so that's actual density, and then the stratified estimates, homogeneous across the strata, but still density, and then probability of occurrence might be environmental drivers, but maybe just habitat, so 0 to 1, presence or absence, and then, hey, we got records. There's maybe opportunistic observations, but we don't have enough data to develop a model. So then this is, Carrie mentioned this yesterday in the sound panel, where there's, we've got the region, and then we've got the species row-wise, and then column-wise we've got the months of the year. So now we're starting to drill down into, here in the red we see the gaps, where we need more data. Obviously winter is more a problem for surveying, and then green is where we've got the best possible data types for doing spatial planning. And then this is getting fed into efforts like marine cadastre for doing BOEM, I guess they call them, for offshore wind energy and oil rig management. So, and then I just want to just highlight something, just the cool trajectory of where this is going. And that's, actually getting at a whale cast. So this is Elizabeth Becker, Karen, Dave Foley, Karen Forney, Jay Barlow, Jessica Redfern. So this is so cool because now we can have these predictive models, and given the environmental conditions, then we can say, okay, here's what we expect today. And now with these oceanographic models like ROMs, forecasting even up to 3 months out, we can say, here's what we expect in 3 months. And if that's within the planning horizon of these other activities, then we can hopefully minimize impacts. So just like I think Mike Powell mentioned, sort of a sound cast, like a forecast of sound. We could interact these two methods, and certainly ground truthing is going to be key. So I'm just going to just mention just the fact that on a finer scale basis, a very commonly used tool is MarkSand that many of you have probably heard of. And this is just taking GIS data layers, crunching them into an optimization algorithm, and you generally you get out an answer based on how you set these goals. And it's just, this is it's an exercise that people do every time. Of course, find filter targets and goals and whatnot. And it's nice to have something like the Ocean Health Index, to have something more standardized, and then trade-off analysis. So, but I just want to close and lead into Evan's talk just by saying that this happened in California. Scientists got together, did this MarkSand planning exercise for allocating where marine reserves should be, and there was incredible backlash because all the stakeholders, none of the stakeholders were brought to the table. And I like this, there was this one quote that I heard Larry Crowder say, I think you got it from Fannie DuVray, but if you're not at the table, you're still on the table. So your piece of pie is going to get carved up and somebody else might eat it, so you got to show up, and that's what Evan's going to talk about, is how everybody can come to the table. So I'm going to skip the issues, we can bring these back up later. And I just want to certainly thank the folks at like Ben Halpern, Steve Katona, other folks, Darren Hardy, huge technical whiz on the OHI team, and then my advisor at Halpern and Duke and others. So here are a few websites that I mentioned. And with that, I'm going to leave 2 questions, quick questions. Yeah.
How do you incorporate uncertainty, especially in the distribution? I guess. I mean, models and I guess visually, I'm sure it's easy way to visually, but there's no, I didn't see any mention in certain values.
Yeah. That's a great point. So that ROC curve, at least with the habitat model, it's actually a cross-validation. So we'll go back. So this is false positives and true positives. So you can think the true positive rate is 1 minus the false negative rate. So that does incorporate this idea of uncertainty. Because you're saying, okay, here's the likelihood of me calling this habitat and it not being habitat. So that would be a false positive, or the likelihood of me calling it not habitat and it actually being habitat. So that's a false negative. And if you're more risk averse, then you're more leery of the false negatives for sure. Something that I need to get out there is this idea of like a minimal loss decision mapping. So here you've got this is actually inspired by work by Paul Wade and Barb Taylor, and then doing this in an aspatial way where they use Bayesian methods to quantify the decision of either of taking in population status and say calling a threat or not, and getting the uncertainty with that, the result. So the idea here is that you've got, let's say, habitat likelihood of encounter on the left, and you've got standard error of that map. Well, if you assign a weight of sort of the risk loss of either operating in that area that has a potential impact, and actually encountering that animal, that might be a high loss of 3, but not encountering low loss. But not operating also has a loss. So you just map that out, and then you get this loss decision, this idea that, given our framework, then here's what I would or wouldn't do. Any other